Class, good day. Welcome to the mathematics class for the senior secondary school. And the first topic we would like to talk about here today is number base. In your junior school course, you would have observed that we may operate numbers in other base rather than 10. So that means for you to operate something like that when you're in your junior school, which means we can expatiate and talk more on it in your senior school. So number base is going to take you through the course of operating numbers together using different counts. For example, now if I should be counting in fives, that means I am in base 5. For me to be counting in 2s, that means I'm in base 2. And the general one that we are used to is counting in 10, which is the decimal or the denary. Decimal or denary is what we are used to. That is our counting system, the general counting system. The idea of you starting your digits from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. You will observe that all the numbers you know is from these digits. If you should call a number as big as it is, no matter how big it is always from these digits. So let's go straight to what we are about to discuss here today, which is number-based system of different kinds. I want to show you a few examples to remind you of what you've done when you are in your junior school. So let's start with something like 0, 1, 0, 1, 1 into base 2. And this is a base 2 number system. This is a base 2 number system. Base 2 number system is always called the what? The binary. We call them the binary number system. There are other names along the line of this course. You will meet different infos that you might need on the way. Now, 1, 0, 1, 1 to base 2. In value is the same thing as this. In value is the same thing as 1 times 2 raised to power 3 plus 0 times 2 raised to power 2 times 2 raised to power 2 plus 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. I would like to show you, or I should take you through these in just to remind you a few things that you might have forgot. This is the main value of this figure here, 1, 0, 1, 1 base 2. But you will observe something is being repeated when I'm writing out the main value, which is 2. So which means this base 2 here has been really working. This base 2 here, it has really worked out a lot. Which means for us to have something like that, so which implies that there is a relationship between the base and this figure that is being repeated. So I want you to take note of that. It is being repeated, and as it is being repeated, that means there is a connection. So you already know that the base of your number is the one that will give you the exact value. Now, aside that, you will also see that each digit picks a powering system. I believe you are seeing what I'm showing you. Each digit picks its own powering system. So which means 1011 base 2 is being expanded as this. Then what am I trying to expand it down to? I'm expanding it down to what? Base 10. This figure is going to give us the same thing as 1 times 8, because 2 raised to power 3 is what? Is 8. Plus 0 times 4 plus 1 times 2 plus 1 times 1. This gives this. This gives this. This gives this. And finally, this gives us this. Please don't be offended by few lines crossing over each other. Alright, so, and this will give me 8 plus what? 0, because 0 times anything is exactly the same. Plus what? Then 2 and plus 1. Also, I did not mention something here. 2 raised to power 0 is 1. You should note that. 2 raised to power 0 is 1. Why is 2 raised to power 0 1? It is proven through indices that any number raised to power 0 except 0 itself is 1. Any number, no matter what, as it is raised to power 0 except 0 is what? Is 1. So 8 plus 2 plus 1 surely gives us a figure. Whatever the figure gives you, it must be in what? In base 10. So I'm only taking you down in line to show you what number system was about when you're in junior school. We have number in base 4. In base 4, you can have in base 5, you can have in any base, any preferred base that you want. You can have in base 4. Number in base 4, an example is, let me choose base 5. An example is 432. 432. And if you want to expand it, this is 0, 1, and 2, and this will give us 4 times 5 raised to power 2 plus 3 times 5 raised to power 1 plus 2 times 5 raised to power 0. So I believe it's not new anymore. You will understand how it is being picked because it is in base 5. For it to be in base 5, then the 5 will be repeated. Let's now take us to something more advanced, because I'm very sure you are not exposed to this when you're in junior school. It's not in the syllabus. So if anybody exposes it to you, what's the just trying to take you ahead of time? So let's look at a figure like this, which is 4ET. 4ET, which is in base 12. 4ET in base 12. The same thing, power it up, 0, 1, 2. This will give us 4 times 12 raised to power 2 plus what? E is standing for 11. E, 11 times 12 raised to power 1 plus 10 times 12 raised to power 0. So your final answer should and must come out in what? In base 10. Now, note something. Note it that in this case, E and T are 11 and 10 respectively. They are 11 and 10 respectively. You should note that. You should note that. So which means in number system, we can use letters to designate digits, numbers that involve 2 digits. Let's go again. That means in number system, number base, we can use letters to represent what? To represent numbers that are in what? That are in 2 digits. Let's say for example, you are dealing with a number in base 16 now. Number base 16, which is called the hexadecimal. The hexadecimal is having a slot of 16 spaces. So which means if you go pick figures from 0 to 9, and there will still be what? There will still be 6 more spaces. 6 more spaces. So in a case like that, how are we going to represent 11? Are you getting it? How are we going to represent 11, 12, 13, 14, and what? 15. So it's going to sound as if you are trying to represent 2 digits. with, you cannot represent two digits with a number. In number base, it will be very, very tedious. So the best thing is they use letter. They rather use what? They rather use letter. So they use letter like A, B, C, D, E, and F. So 10, I missed 10, sorry. 10 also, there's a 10. 10 is, sorry, wait, I'll last, I'm not got the lady. Mish, I'm not got the lady. I'm going to go to I'm not got the lady. In hexadecimal number system, we have 0 to 9 spaces, followed by the space for 10, 11, 12, 13, 14, and 15. So in a case like this, you cannot just represent a number using two digits. So the best thing to do is what? Just represent them with a particular symbol. So generally, the scientists have agreed that in hexadecimal system we are having these to represent the following figures. So in hexadecimal number system, from 10 to 15, A, B, C, D, E, F are representing them respectively like that. Now let's go to the idea of conversion. Let's go to the idea of conversion in number system. Conversion in number system. I know you are not new to it, so I want you to just put something down as like a way of reminding you to have a thing to remind you. So let's look at 4ET to base 12 to base 10. What will happen if you have to convert 4ET base 12 to base 10? Something like that has been stated earlier. So which means 4ET base 12 will be done. Now I want to use the idea of the powering method or the the repeated multiplication method. So I will surely teach you these two methods in this video clip. So let's start with the powering method. The powering method is the idea of you numbering the digits according to their placement. The first digit, which is standing for the unit digit takes power 0. The 10th digit takes power 1. The 100th digit takes power 2. Like that, continuously, like that. So you pick your first digit, which is what? According to this place, we have 4 as our first digit. We have the second digit to be what? E, and we have the last digit here to be what? To be T. So in a situation like this, where 4 is your first digit, you pick that first digit, which is 4. Then you have to multiply with the base. The base here is what? 12. So I'm going to let our color help us. So 4 times 12, then raised to power what? Raised to power what? 2. So the power here is what? 2. So you continue those and you pick the next power, which is having the color there. So the next thing is going to be picking up the digit plus what? Plus the digit. The next digit is E. E is standing for 11. So 11 times the base, which is 12 again. All raised to power what? All raised to power 1. All raised to power 1 plus finally the last one, which is T. T should be standing for what? T is standing for 10. Then times what? Times 12 raised to power 0. Don't forget, any figure raised to power 0 is what? Is 1. So I have 10 times 1. Then I have 11 times 12. 12 raised to power 1 is 12. Then 4 times 1, 44. So don't be surprised if you have that as our final answer because I've explained earlier. So the next thing now is 4 times 144 is the same thing as 576 plus 132 plus 10. 132 is 11 times 12 and 10 times 1 is 10. So finally we have 718 is 10 to be the same value as what 4et in base what is 12. So that is our conversion using the powering method. Now, in case you are now asked to divide, you are asked to divide. You are not asked to divide. I mean, you are asked to convert 2077 to base 8. To base 8. How do we go about it? The method we use here is called the repeated division. I said I will still teach you how to use the repeated multiplication. So now in this case, use the repeated division. Repeated division is the approach you are going to do here. Use it. What will you do? What you will do is very simple. Just divide 277 by 8 repeatedly. You divide it repeatedly until further division is impossible. You keep dividing until further division is what? Impossible. So this is called the repeated division. Note that the remainder is always written from the baseline down up. You write it from the baseline to the top. So 2077, we are trying to divide it and note our remainder. We want to divide it and note our remainder. What are you dividing with? You are dividing it with the base you want to convert to. Since you are trying to convert to to base 8, you have to use what? You have to use 8 to divide it. You keep using 8 to divide it. So when you use 8 to divide 207 at first, you will have it to be possible by what? 259 times. 8 will divide 2077 in 259 times, but there will be a remainder of 5. So 8 again divided by 259, you will use the same 8 to divide the multiple that you already have, which is 8 divided 259, you have 32. This time it will remain 3. 8 on 32. 32 is a factor, 8 is a factor of 32, so this time you have 4 and there will be what? No remainder. And that's not the end. Truly, the division of what? 8 and 4 is not having any quotient. That is, 8 cannot divide 4. But I want you to know that the number of times 8 will divide 4 is 0. So you don't stop your calculation here. Don't say 8 divides 4 then you stop. Since you know that 8 and 4 is impossible, like to you, just say 8 and 4 is 0. How many 8 will I say in 4? 0. But it will still remain this same 4. So this same 4 will be transferred as what? As the remainder. So which means you have this. So what are we trying to say here? The other time, you have to write it from the baseline. Write from this 4 down to 5. So you write it from 4 down to 5, which means 2077 in base 10 is the same thing as what? 4035 in base 8. So that is the idea of conversion. That is the idea of conversion. I believe I reminded you very well of how to convert. Now I'm taking it up to how to use the repeated multiplication method. So I will use just one example to explain the idea of repeated multiplication. Now, the example 2, which is going to explain to us how to use repeated multiplication. We are trying to convert. Let's try to convert 1264. You observe I did not call this 1264. Yes. You don't call it 1264 because it is our normal counting base number, which is our decimal number that you can call out like that. When you are in other bases, you call them digit by digit. You respect the rule by calling it digit by digit. So this is 1264 base 8. We are trying to convert it to base. We convert this to base 10. Trying to convert this to base 10 using the what? Using the repeated multiplication. Using repeated multiplication. The reason why most teachers don't choose to talk about this method is because most of the time it confuses students. But don't be scared. We try our best to explain. Now, how do we go about it? The first digit here is 1. The first digit there is what? 1. You have to multiply it to its base. Multiply 1 to its base and note your what? Note your result. Your result is what? Is 8. But that's not the end. The next thing is to add to the next digit in the question. The next digit in the question is what? Is 2. So you have to introduce that 2 and add it to it. What's your final answer? What's the answer in that case? Your answer in that case is what? Is 10. That's not the end. It's a repeated multiplication. So you have to multiply another 8 until you get to the last digit. Multiplying another 8, I'm having 8 plus what? Plus the next digit again, which is what? 6. So I am to add 6, which will give me what? 86. What will I do next? Repeated multiplication. You have to multiply another 8. Multiplying another 8, what am I going to do? Multiplying another 8, I will find my result, which is 688, then add it to the last digit. So you observe that at the end, you are having your digits. You are having your digits as what? As the figure you are to be adding, while your base as the figure you are to what? You are to be multiplying. So I'm trying to write it out so that you see what I'm trying to say. So you see that at the end now, 1 is the first figure, then 2, which is being added to it, then 6, which is being added, and finally 4 is added. So 1, 2, 6, 4, base 8 is going to be what? Is now going to be what? Finally, it's going to be 692 in base 10. So that's it. 1, 2, 6, 4, base 8 is the same thing as what? 692 in base 10. So that is the idea of using repeated multiplication. So I want you to note some things. Note this. There are some rules you need to know. So you write it down as I'm saying these rules. The first rule is that what? Anytime you are using powering method, short rules. Anytime you are using powering method, the first thing is powering method or what? Repeated what? Multiplication. It can only take you down to base 10. So don't be confused. Anytime you are using powering method or repeated multiplication, it can only take you down to what? Base 10. And secondly, second rule, anytime you are using the repeated division, anytime you are using the repeated what? Repeated division, then this can only take you away from other bases to base to your preferred base. It can take you from what? Other base to your desired base. That is, for example, if you are trying to move from base 10 to other bases, now you have to use repeated division. So you cannot use repeated division on a number that is not in base 10 already. So that's the rule. The rule is what? Is very simple. So let's assume base 10 is our gate. Base 10 is like our main gate. The main gate of number base. So when you are trying to go from base 10 to other base, you can use what? You can use the idea of what? Repeated division. Repeated division. This is to any other what? To any other base. But when you are trying to go from other bases, you now want to move to what? To number base. Then you will use what we call the repeated multiplication or what? The powering method. So So that is the idea. Maybe this chart will help you out.
So the main gate is number in base 10.
So let's say for example I'm trying to go from base 2 to what? Base 8. Are you guys what I'm trying to say? There's no how you are going to go from base 2 to base something like base 9. Let me say base 9 to be sure, so that people will not criticize my words. So let's say from base 2 to base 9. You have to get to what? To base 10 first before you go to what? Base 9. How do you go from base 2 to base 10? You go from base 2 to base 10 using the what? The powering method or the repeated multiplication, and you go to this one by using the what? The repeated division. So that is the idea. That is our first class on number system. So stay tuned as I'll take you down to other complex aspect of number system. Thank you.